Okay, so today's lesson piggybacks off of yesterday's lesson. Once again, it's simplifying radicals. It's just this time with variables. Okay, so let's have an example here to kind of show what that looks like. I'm going to start with square root of 80x squared. So once again, just like yesterday, what we're trying to do is pull out all of the perfect squares that are kind of hidden inside of 80, and this time with our variable as well, x squared. So started off just like we did yesterday. Started off with just taking care of your coefficient, the number first. So we'll take care of 80 first by doing the factor tree. Should be pretty comfortable with the factor tree by now. So break it down. Okay. So now that I have all my prime numbers here, I got all my prime factors, we can circle pairs since it's a square root, and we take out one of that number from each of our pairs to the outside. Don't mess with the x squared yet, just leave it alone. So on the outside we have 2 times 2, and on the inside we have to throw that 5 back in since it doesn't have a pair. And leave the x squared there because we haven't touched it yet. Next, need to just do 2 times 2. Okay. So basically, we simplified the square root of 80 into 4 times the square root of 5. So we've taken care of our 80. Now it's time to take care of our variable. As the variable is written right now, it's x squared. The 2 is the exponent, and it's actually called exponential form. So the way that we simplify this easily, the strategy behind it, is to put it into what's called expanded form. So we take that variable and we actually show how many times it's being multiplied by itself. So since the exponent is 2, there's 2x's being multiplied basically by itself. X is being multiplied by itself because of that 2 for the exponent. Now, just like we did over here with our factor tree with our numbers, we do the same thing with our variables. So you circle your pair of x's, and you get to take out one x to the outside and put it with the 4. And there you have it. There's your final answer. Now what we actually did was we did the square root of 80 and we simplified it, which gave us 4 times the square root of 5. And then we did the square root of x squared. Well, x squared is actually a perfect square. It's just x times x, just with variables. So that's where the x comes from on the outside. Okay, let's do a couple more. Move my camera down. Alright. Number 2. We got 3m times the square root, oops, well, it's kind of big, times the 40 times the square root of 40m cubed. Now don't let this exponent confuse you. That cubed only belongs to the m. It does not make this a cubed root. This is still a square root. It just happens that our variable has an exponent of 3 attached to it. Okay, once again, just kind of ignore these, the 3m out here, and just kind of ignore your variable for a second. We want to take care of this number here, the 40. So break it down using your factor tree. Okay. Once again, square root, so we're circling pairs. So you get to take out 1, 2 for that pair of 2's, and then put it on the outside with that 3 and that m, all being multiplied together. And then on the inside, you got to throw back in the 2 and the 5 since they do not have a pair. And we have not touched the m cubed, so keep that m cubed on the inside. Okay, next just multiply. 3 times 2 is 6. 2 times 5 is 10. And we're going to do basically the same thing we did in the previous problem. We're going to write this variable that's in exponential form right now. We're going to write it in expanded form. So m to the third, that means I have 3 m's being multiplied basically by itself, m being multiplied by itself 3 times. Okay, once again, circle pairs of variables. Got a pair of m's here, and I get to take out 1 m for each pair. So on the outside, I got 6m times m. On the inside of my radical, I got 10m. Okay, there is one more step. This might seem a little confusing, but now we have m times m out here. We don't want it to keep it in exponential form for our final, we don't want to keep it in expanded form for our final answer. We want to actually put it back into exponential form. We just put this one in expanded form so we can see where our pairs are. But now, so we have m times m, that's the same thing as just having m squared, m times itself. And then we have 10m still on the inside of our radical. And that is your final answer. Okay. One more. So I'm flipping mine on the back so I have space. So number 3, we have 4 times the square root of 64 x squared y to the 5th z to the 3rd, or z cubed. Okay, so once again, kind of ignore the 4 out there, kind of ignore your variables for the first step. Just take care of breaking down this 64. Thought I made a mistake there for a second. Okay. No, I definitely made a mistake. Okay, let's start that over. Oops. Start from scratch. Sorry about that. 4 times the square root of 64 x squared y to the 5th z to the 3rd. Where my mistake was when I was doing my factor tree, I accidentally said 2 and 30. It's 2 and 32. So don't make that mistake. Be careful. Take your time with it. So break it down using the factor tree. And now circle your pairs, since once again it's a square root. And look at that. Just as a reminder, when you have everything having a pair over here, when all of your prime numbers have pairs and there's nothing left over, well, that means that the number you started out with was a perfect square. And you guys probably knew that 64 was a perfect square. You're just so used to doing the factor tree that you just did it anyway, which is fine. Factor tree will always give you the right answer, but just know when you circle, when everything has a pair, that number was a perfect square. So you take out a 2 for each. Put them on the outside with the 4. I'll just have to put it down here for the sake of room. So the 4 is already there, so we keep it there. Take out 3 2's. Okay. And then we haven't touched any of our variables yet, so we leave them alone. And nothing went back on the inside once again because there's nothing left over. 64 was a perfect square. So 4 times 2 is 8, times 2 is 16, times 2 is 32. Times the square root of x squared y to the 5th z to the 3rd. Okay, so now we're ready to deal with our variables. And I'm going to need a lot of space here, so I'm going to go all the way down here. Because what we have to do is we have to write the x squared, y to the 5th, and z to the 3rd all in expanded form. So I got 2 x's from the x squared, got 5 y's from y to the 5th, and I got 3 z's from z to the 3rd. Circle your pairs of variables. So I got a pair of x's, 2 pairs of y's, and a pair of z's. And then this y and this z, well, they don't have any partners, so they're not a pair. Take out one variable for each pair that you have. And so on the outside, got to move this down again. Hopefully I don't run out of room. We got 32. Then we got an x from that pair of x's. We have 2 y's for those pairs of y's. And we have 1 z from that pair of z's. And then on the inside we still have yz. Now whenever you have variables right next to each other, you don't need to put the multiplication dot, like I didn't put it right here. I just kind of do it over here because in my brain I know that I'm not finished. So I know whenever I have a y times a y, I need to do something with that. Right now it's in an expanded form. I need to put in exponential form. So I got to take those 2 y's that are being multiplied by each other and make it y squared. And there you go. There is your final answer.